Okay, hopefully you've had a chance to look at the law of sines notes and start that. And even if you haven't, this will be really good practice then. So here's a word problem that you might see something like. It says, on a small lake, you swam from point A to point B at a bearing of northeast 28 degrees. We're going to talk about what bearing means here in a second. You then swam to point C at a bearing of northwest 58 degrees. Point C is 800 meters due north of point A. How many total meters did you swim? So we kind of got to get a picture going here. So I'm just going to draw kind of a random small lake. I know it's really pretty. Pretend like that's my lake. Bearing. Okay, so let's work backwards here. I'm going to grab another piece of paper really quickly and talk about bearing, and we'll come back to the problem. So when we're talking about bearing, we're talking about like directional stuff. So hopefully we know our directions and know, like on a compass, this is north, south, east, and west. So if I'm going to say something like, we can use the actual problem, is northeast 28 degrees. What we're saying is we're going to draw in a line of north, and you'll always kind of see it as a dashed line. And then from that line of north, we're going to go east 28 degrees from that line. So 28 degrees, think about what, straight out to the east would be 90, halfway would be 45. So if I was going to draw northeast 28 degrees, it might be something like this, okay, in that direction. And what we're saying is this angle then is 28 degrees. So think about other examples here. So what if we wanted to go, I'm just kind of making up stuff, southwest, let's just make it easy, 45 degrees. And sometimes you'll hear like west of south, east of north, like some people will say this differently, but this one's kind of one to think about then. So we're actually going to draw in a line of south, so we're saying, hey, this direction here is south, and from this line of south we're going to go west 45 degrees, so west is this way. So think about where 90 would be, so 45 would be about there, and we're saying that's 45 degrees to the west of south then. So hopefully that's kind of making sense. Another way that, interesting enough to say bearing, is you can just say something like, 200 degrees from north. And so what we mean then is we're going to have to go all the way around, so from north, 200 degrees from there, well, this much would be 90, all the way to straight down south would be 180. So 200 degrees would be just past that. So there's another way to deal with bearing. So they'll kind of come up in problems and you'll see them. There are watchets with the web assign that will help, but I just wanted you to get an understanding of what bearing even is. So back to the problem. If you kind of you have to take in all the information here and understand that this last line here where it says point C is 800 meters due north of point A, well, point A must be at the bottom then of our picture, kind of. So I'm going to put point A down here kind of on the lake shore, so that it makes sense that we're going to be going, across the lake a certain way here. So again, so it says you swam from point A to point B at this bearing. So if I go ahead and put in a line of north here, should be straight north, and I don't know how far it extends. I'm just making a dashed line to represent north. And I'm going to go at a bearing of east of that 28 degrees. Again, dashed line here. 28 degrees isn't very, like I said, it's not very big, so maybe something like that. And I assume I'm getting to the other shore. I mean, this is just an assumption, but I don't know. Maybe I turned in the middle of the lake. It's hard to know, but we're just kind of going with it. So we're saying this right here is what's 28 degrees. Then it says I swam to that next point, C at a bearing of west 58 degrees, or 58 degrees west of north. So here's what's interesting. You're going to draw in a new line, so a new line of north. So it's not from this line of north, it's from where I'm at point B. So I'm going to use a different color. So it's still north, so it should be parallel to your other north, but there's a new one, and I'm going from there. And so this time I'm going west, 58 degrees west. So think 45 is like directly, straight out. And so my picture's not perfect here, but it's kind of like I'm getting to the shore probably over here again, somewhere here. And again, not perfect, just go with it. I'm going to call that point C. And then my picture kind of makes sense. Then this is what's 58 degrees. So from this dashed line to this, Like I said, that obviously looks more than 58 degrees, okay, but it's close. And then the reason I wanted to connect it like that was because point C, it says, is 800 meters due north, so that I can be like, okay, well, here's the rest of my triangle then. So I'm kind of making a triangle out of this right in here between A, B, and C. And remember, I swam along, or you swam along A to B and then B to C, so I need to find those two sides to figure out how far it was overall. So a couple important things here then. You need to figure out some of the other angles. And here's where these two lines of north can be really, really important to you. The lines of north are going to be parallel. Okay, think back to geometry. I'll kind of draw over here. If I've got two parallel lines and they're cut by a transversal, you should know some things then. And so look at what I've got right here. The 58 degrees is like this one right here. And then this angle right here is inside of my triangle, and one of the ones I want to know, well, I can't even mark them on purpose, and maybe I'll use two lines since there's one line down here. Those should be congruent. If you think about it, they are alternate interior angles to each other. So this one's got to be 58 degrees as well. Like I said, I know my picture's not perfect. It looks a little more than 58 degrees, but it's not bad either. So this is going to be helpful then because I've got 58 degrees, I've got 28 degrees. To use law of sines, I need to have an angle and a side across from it, and this is the only side I know. But now I'm going to know this angle because I can subtract from 180. So I can do 58 plus 28, subtract that from 180, and get to 94 for angle B. Okay, and if you didn't follow that, I've got to do 180 minus 58 plus 28. So angle B is 94 degrees. Okay, now I can actually use law of sines to find the two things I want to find, because the two things I want to find are this side, I'm going to call it C since it's across from angle C, and A since it's across from angle A, and I want to add those together because remember in the end I want to know how many total meters I swam. So if I go ahead and set up law of sines then, I'm going to have sine of 94 degrees over 800. There's the angle and side I know that are across from each other, and it doesn't matter which thing I solve for first here. So if I want to solve for A first, I'm going to do sine of 28 over A, and then I'm going to go ahead and cross multiply. So I'll have A times sine 94 equals 800 times sine 28, divide by sine of 94. And here's some important things. Okay, do not round until the very end. You need to type this all in your calculator at once. If you haven't been doing that and things haven't been going well, that's probably why. Another thing is you need to make sure you're in degree mode on your calculator. If you're not in the right mode, it's not going to work out. So you can see I'm in degrees, and then I'm going to type this in all at once. So I've got 800 sine 28 divided by sine 94. And now is when I'm going to round. Okay, so I'm not rounding until this point. So now I'll maybe round to the tenths. It doesn't really say, so I can kind of decide. Maybe I round to the nearest whole. Doesn't matter. I'm going to do 376.5 though. And that's in meters. And then I've got to do the same kind of thing to find side C so that I can add them together. And if you haven't noticed this already on other stuff you've done, you're going to use this same beginning part again, because that's the one I know for sure. I don't want to use this rounded value I just found because that's rounded, so I'm not going to get a very good answer. So I'm still going to use sine 94 over 800, but now since I'm finding side C, I'm going to use the angle across from it, so sine 58 over C. So obviously the cross multiplying is going to be very similar. I'm going to have C times sine 94 on one side, I'm going to have 800 times sine of 58 on the other, and divided by sine of 94 again. So again, typing that into a calculator. By the way, another trick that I've tried to teach you in the past is you can get this same entry back by doing second enter. Get the whole entry back, because what's the only thing I need to change in it? I just need that, change that 28 to a 58, so then I can go back over here and make this a 5. Don't have to type it all in again, but it doesn't really matter. Again, if I'm going to round the last one to the nearest tenth, I'll round this one to the nearest tenth, so it'll be at 680.1 meters. And remember, the question was how many total meters did you swim? And you swam from A to B and then B to C, so I need to add these two together. So answer in the end is going to be 376.5 plus 680.1, so 6, so looks like 1,056.6 meters total for that swim. Okay, so that's one problem. The next one I want to show you is actually in the book, and I know we don't really have our books anymore, but you can look at one under a desk if you'd like to, but I will project it, so it'll be fine. Let me get my book over here. So it's on page 415, number 27. Like I said, I'll just project it right here. We're talking about a plane, and the reason I picked this one is because in the end we're finding the angle. So instead of finding the side length, we're finding the angle. It says a plane flies 500 kilometers with a bearing of 316 degrees clockwise from north. So there's another kind of bearing too that we talked about. So, you know, drawing that, they actually have it for you. And so hopefully it can make sense to you that if I'm going 316 degrees from north, over here where the plane is, well, if I do 360 minus 316, it's going to be 44 degrees left over here from north to this path. So that's why they've got 44 right here for you, because 316 around, so 44 right here. So that's from Naples to Elgin. And then the plane turns and flies 720 kilometers from Elgin to Canton. Find the bearing of the flight from Elgin to Canton. So they want a bearing up here. Okay. And I'm going to go ahead and probably redraw this on another piece of paper just because it's going to be hard to follow because I need to write on it and everything. Notice Canton and Elgin are not really on a straight path to each other, but Canton and Naples for sure are straight east and west. That's going to be important to us. So again, I'm just going to kind of copy the picture over so that I can use it the best I can and kind of keep in mind what we're trying to find. Okay, we're trying to find the bearing up here at Elgin. Oops, it doesn't look like 720. 720. Okay, I think I got everything from the picture. Okay, let's see what we can do with that. So, again, keep in mind, we're trying to find a bearing up in here from Elgin to Canton. Okay, I'll write that over here. Bearing from Elgin to Canton. And we can write it either way. We can write it either in terms like they did, like 316 degrees from north, or we can write it as our northeast or southwest like we did on the other problem. So, like when I'm looking at this problem right now, since these were straight, remember these were straight east and west of each other, this has to be a 90-degree angle down here in this corner then, because if this is north and this is west, that's got to make 90 degrees. So if I do 44 minus, or 90 minus 44, this angle in here is 46. That's going to be really helpful right away, because then I have an angle and a side across from it, so I can find other angles, other sides, like whatever I want to do here. You kind of have to have a plan too. You're trying to deal with this angle up here. So it's like, well, do I even need to know this side? Or can I even find this side? Well, no, I don't know either one, so it's not going to be helpful. So really, I've got this side angle across from this side. I can find this angle, and why would that even be helpful? Well, if I know this angle and this angle, I'm going to be able to find that one because they add up to 180. So let's go ahead and find the angle down at Canton, and I will call it C just for it being a little bit easier. So I'm going to do sine of 46 degrees over 720, these two, equals sine of C for Canton over the 500 meters. Those are, or wait, I have two different things here. Meters, kilometers. They're both kilometers. This should be kilometers as well. And then I'm going to cross multiply from here. So it's a little different with an angle. I mean, I'm still cross multiplying the same way. But as far as the rest of what I'm going to write, so that looks similar. I'm going to divide by 720. And here's where some people get stuck, because they either go ahead and type this in a calculator and get a decimal and then are like, wait, what did I do wrong? or they don't realize that they should just keep going. So go ahead and leave this the way it is. Just type it in the calculator last. How you get rid of the sign, we'll think, what undoes sign? We've talked about this a lot in the past. Inverse sign. So I'm going to do inverse sign to both sides. Okay. And that's going to undo that. Remember that our answers for inverse sign can be in quadrants 1 and 4, so we're kind of like thinking about how that makes sense, you know, what that really does to this problem. But since we're talking about positive real life numbers, like we're talking about quadrant 1, so our calculator is going to give us the answer that we want. Again, so let's take this in all at once. So let me show you on the calculator that you don't need to ever round anything. Just type it in all at once. So second sine, I've got 500 sine 46. Make sure to close that parenthesis. Divided by 720. Let's close that parenthesis. So I'm doing inverse sine of all of it. Now let's round. So again, you kind of have to decide what you want to round to. This angle and a lot of angles on WebAssign, we rounded 2 decimal places. Not everyone, but a lot of them. So I'm going to do 2 decimal places. So 29.97 degrees. So remember, to our picture, like that's this angle right here. So now I can find this whole angle by subtracting from 180. So if I do 180 minus 29.97 plus 46, that should give me the angle at Elgin. So back to my calculator. 180 minus. So 104.03 degrees. So we've done a pretty good job here, but we still haven't quite answered the question. They didn't ask for like the angle between the two lines here. Remember, the question asked for the bearing from Elgin to Canton. So here's where maybe it's a little bit tricky to think about. I've got to think about from north. So I really need to draw in another line of north at Elgin right here. And think about, well, what is it all the way around to there? And here I kind of was covering it with my hand. All the way around to here. So there's a couple different ways to deal with this. What I would think about is, let's think about those parallel lines again. I can split this then. Like I can go ahead and draw in the line of north all the way down, and then I've got my parallel lines cut by a transversal again. So it's kind of hard to see in here, so maybe I'll redraw the picture to help you notice it. Redraw it down here. If this one right here is 44 degrees, then this part right here has to be 44 degrees. Just this part is what I'm talking about with this. Okay, those have to both be 44 degrees because they're alternate interior angles. Why does that help me? Well, it lets me know how much further this is then, because otherwise it was kind of unclear. So if that's 44 degrees and the whole thing's 104.03, then this has to be 60.03 degrees right here. Again, it's really hard to see my writing. Let me write it bigger. That has to be 60.03. That has to be 44. Okay, so it's really this picture up here. This is 44. This is 60.03. So what I'm trying to say then is, if you think about it, if I'm going here to here, that's 180 plus this 60.03 degrees. That's right there. Okay, and what I mean is the north to south line. That's got to be 180. It's halfway around a circle. So I think if we do 180 degrees plus the 60.03 degrees past that, that this has to be, we'd have our bearing in terms of from north. So 240.03 degrees from north. Okay, so that's one way to say it. The other way to say it would have been, once I got that 60.03, just deal with that. So it's to the west of south, so I could just say south, make it look more like an S than a 5 there, 60.03 degrees west. Okay, so either one of those is totally fine for an answer. Hopefully you could follow that with me like splitting through this, having the alternate interangles. But yeah, hopefully that should be enough to get you through the WebAssign for now for 6-1, and we'll go on to 6-2 soon.